Hello everyone. Welcome to the version 2 of the practice exam. So if we look at number 1 says if a parabola's vertex intersects the x-axis, then the discriminant is equal to 0. So what that tells us is as such. So if the parabola intersects the x-axis, parabola's vertex intersects the x-axis, that tells us that there only exists one solution. And so let's think about that. So the discriminant, once again, is the radicand of the quadratic formula. So if that is equal to 0, then we're going to have the square root of 0, which gets completely eliminated because square root of 0 is just 0, leaving us with negative b over 2a, which is in fact the axis of symmetry. And that does make a lot of sense because if it intersects at the vertex, then the x value will be the axis of symmetry. So number 1 is indeed true. So number 2, here we have in a quadratic linear system, it is possible to have infinite solutions. So we just have to remember quadratic linear means that we have one parabola and one line. Doesn't have to look like this, but if there are infinite solutions, that entails that there are infinite points and infinite points of intersection, and in that case that's impossible. It's impossible for a parabola and a line to be intersecting everywhere. Now in number 3, here we have if x is less than 0. So that what that means in English is that x is a negative value. So if x is a negative value, then this says square root of negative x. If x is negative, then therefore negative x is forced to be positive. So if we take the square root of a positive value, then that's no longer imaginary. Last one, number 4. The product of two complex numbers in the form of a plus bi will always result in a complex number. So we just have to remember, what does it mean to be a complex number? A complex number is the sum of a real number and an imaginary number, which is b times I. As long as there's the existence of I, it's imaginary. So even if we think about worksheet number 30 when we had conjugates, right? Something like, let's say 1 plus I times 1 minus I, that would result in an integer. But integers itself are still complex numbers because they can be written in the form of a plus bi. So for example, let's say we have an integer 2. The integer 2 can be expressed in this form because it's technically 2 plus 0i. So therefore, we can think about complex numbers as just any numbers that we currently know in existence. They composed of real numbers and imaginary numbers. So number 4, therefore, is also true as well. Okay, let's look at number 2. So number 2, here we have consider the system shown below. Here they give us a linear equation and then the equation of a circle. So we want to see the two solutions of the system can be described as blank. So notice here that they're not asking for specific solutions, but rather the type of solutions. So that indicates to us that we're going to have to use the discriminant at some point, unless you want to solve the entire system, which is more time consuming. So looking at the first equation, let's first isolate y. And let's do that by, you don't have to do it this way, but you can add y on both sides and then subtract 4, giving us y equals 2x minus 4. So from there, we can use that to substitute into the equation of the circle, giving us x plus 3 squared plus, and we have to remember to put into parentheses 2x minus 4 squared as such. So from there, multiplying the x plus 3 out, again, we cannot distribute exponents. This will give us x squared plus 6x plus 9. And then in the 2x minus 4 squared will give us 4x squared minus 16x plus 16 is equal to 8. Okay, so from here what we can do is combine like terms. So combining all the like terms on the left side gives us 5x squared minus 10x plus 25 is equal to 8. And in order to solve for the solutions, we have to set the equation equal to 0, thus giving us 5x minus 10x plus 17 is equal to 0. So like mentioned before, the answer choices only talk about the types of solutions. So what we're going to do is use the discriminant to find the types of solutions. And so that's going to give us our discriminant, b squared minus 4ac. So substituting in our values, a is 5, b is negative 10, and c is positive 17. So then that's going to give us negative 10 squared minus 4 times 5 times 17. Or in other words, 100 times negative, not 100 times, 100 minus 340, which gives us negative 240. So once again, the discriminant is the radicand of the quadratic formula over here. So if we imagine there to be a negative in this radicand, or a negative radicand, we know that for sure that's going to give us an imaginary solution, or in other words, not real. So the negative discriminant tells us there are imaginary solutions. So if we look at our answer choices, then we can see that the answer choice is, in this case, number 1. So even though we can eliminate the other ones, something I want to highlight is answer choice number 4. Notice here that it says 1 rational or 1 irrational. Kind of like when we talked about the complex, what was I saying? Oh, the complex conjugate root theorem, how we said that if we have imaginary solutions, there are always 2 of them. That's the same thing for irrational solutions. For example, let's say we have x squared is equal to 5. If we take the square root of both sides, we're always going to get 2 irrational solutions, plus minus square root of 5. And so this situation where it's 1 rational and 1 irrational is just straight up impossible. Okay, let's look at number 3. So number 3 says, which of the following complex numbers is equal to this expression here, given that I is the imaginary unit? So what we can do, there's multiple ways to go about it. So this is the first thing that we can do. So taking the original, what we can do is distribute the negative to each term first. So distributing the negative to each term gives us negative 9i squared plus 6i as such. From here, we can combine like terms of the i's, thus giving us 5 plus 18i minus 9. And because we know that I squared is negative 1, we could substitute it as such. And then simplifying even further, we can combine the like terms of 5 and 9, giving us 14 plus 18i. And that gives us answer choice number 4. And so let's say you didn't go about it that way. Let's say you decided to simplify first. And again, there's nothing wrong with that. So simplifying first, we can replace the I squared in this term here with negative 1. And simplifying further gives us 5 plus 12i minus negative 9 minus 6i as such. And again, we keep it in parentheses because we're subtracting the entirety of this entire expression. And then upon distributing the negative and combining like terms, gives us the same exact answer that we saw before. Okay, let's look at number 4. So number 4, I made a typo on answer choice number 4. This should say minus, oh whoops, what the heck? Yeah, that should say minus instead of plus. So here they tell us we have 2 roots. We have x equals plus 3 plus minus 2i. And so we can go about this in 2 ways to determine the quadratic equation. So again, it's not time efficient to find the solution of every single one of these equations. It's just not worth it. So what we can do instead is either reverse the solving of x, or we can find the sum and product of the roots and use that information to find the equation. So going with method number 1, if we were to reverse the process of solving for x, we can subtract 3 on both sides, thus giving us x minus 3 is equal to plus minus 2i. From there, because we're trying to create a quadratic equation, we're going to square both sides of the equation as such, thus giving us x minus 3 squared equals negative 4. And then multiplying out the left side gives us x squared minus 6x plus 9 is equal to negative 4. And because we want it to be equal to 0, like all of these answer choices, we're going to add 4 on both sides, thus giving us x squared minus 6x plus 13 equals 0. Now this is going to look a little bit confusing because our answer here doesn't exactly look like any of our answer choices up here. So what we can do is create an equivalent equation by multiplying by 3. So if we multiply the entire equation by 3, that's going to give us 3x squared minus 18x plus 39 is equal to 0. So another really good test-taking strategy that we can employ is something as such. So notice that all of the coefficients are the same, but the main difference is that the signs that join these 3 terms. So what we can do is once we get our answer, we know that our signs are not going to change because we're just multiplying by a constant. So what we can do is just focus on the signs itself. So we first start with subtraction and then we have addition. So we don't even need to do this times 3 if we didn't want to, because of the fact that all the multiple choice answers are basically the same with different signs. So we just have to ensure that we have a plus and a minus here, and then boom, we're done. Now, if we chose to approach it the second way, using the sum of roots and product of roots, we would have to add our roots together and then multiply our roots together to find values for a, b, and c. So for the sum of roots, we have to remember that is also known as negative b over a, and that gives us, in this case, 6 over 1, while the product of the roots is c over a, and that gives us 13 over 1. And so with this in mind, we always want to set a equal to 1 because it doesn't change the value of whatever we had calculated, and it's just the easiest. So from there we have b. Well, if negative b is positive 6, then that tells us that regular b is going to be, in this case, negative 6. And then c itself is pretty straightforward. That's just 13. And so that gives us our equation. The same equation as before, x squared minus 6x plus 13. And again, we got to multiply by some sort of constant to ensure that we have our answer choices as such. Now looking at number 5. Number 5, here we have write in simplest a plus bi form. And so from here we got two methods. Let me show you the first one. What we can do first of all is to, oh wait, what did I do? So what we can do is replace everything that we know is true. So again, we know that I squared is equal to negative 1. And now I to the 7th, we can rewrite I to the 7th as I to the power of 4 times I to the power of 3. I to the power of 4 is positive 1, while I to the power of 3 is negative I. Hence why I substituted I to the 7th with negative I. And then we also see here that square root of negative 16 simplifies to 4i. And again, there's no plus minus here because it's not an equation. We're just simplifying regular square root of negative 16. And then from here, let's simplify. So this gives us negative 12 plus 5 over 2i. And then 8i minus 4i is 4i as such. And now simplifying further, we can multiply these two terms. And so again, you can put it into the calculator or you can break it down as such. Remember that multiplying a whole number by a fraction is the same thing as dividing by its denominator and then multiplying by its numerator. So what do I mean by that? That means 4 divided by 2, that gives us 2, and then 2 times 5 gives us 10. So this should give us negative 12 plus 10i squared, because I times I is I squared. And again, because I squared is negative 1, substituting that gives us our final answer of negative 22. So again, here, we can't exactly write it in a plus bi form, but again, technically, this is still a complex number because we could technically write it as negative 22 plus 0i. So it still is complex, but it's unnecessary to write that plus 0i. Now, let's say you didn't think about substituting first on the test. What we can do as well is also, well, first we can rewrite the negative square root of negative 16 as 4i. Thus becoming 4i when we find the difference between the two terms. And then now we can multiply as such, giving us 12i squared minus 10i to the 8th power. And again, using our identities, we can replace I squared with negative 1, and I to the 8th power is going to be positive 1. And that gives us our same answer of negative 22. Okay, let's look at number 6. Number 6 was very similar, or is basically the same thing as what we saw in number 4. So here we have one root of 7 plus 6i, and they want us to write two quadratic equations. So by the complex conjugate root theorem, we know that there must be two complex solutions, both the positive and negative version as such. So if we were to use the method of reversing the solving of x, we would first subtract 7 on both sides, thus giving us x minus 7 equals plus minus 6i. And then square rooting both sides allows us to create the quadratic equation, and that gives us x minus 7 squared equals negative 36. Multiplying out the left side gives us x squared plus minus 14x plus 49 equals negative 36. So from there we can isolate or set the equation equal to 0, giving us x squared equals x squared minus 14x plus 85 equals 0. Yes. Okay. So again, the question is asking for two quadratic equations. So that is one possible answer. And just like previously saw, we can just write or create more equivalent equations by just multiplying both sides by a constant. So we can multiply by 2 on both sides, we can multiply by 3, you can multiply by a negative, a decimal, whatever you want, it really doesn't matter, as long as they're equivalent to the original equation as such. Okay. So let's look at method number 2. So looking at method number 2, we have sum of the roots and product of roots. So for the sum of the roots, if we add them together, that's going to give us, again, negative b over a. In this case, that's going to be 14. While the product of roots represents c over a, or in other words, in this case, 85 over 1. So again, we're just going to set a equal 1 just to easily find what a and b and c are. So in this case, if negative b is 14, then b itself is negative 14, and then c is just 85. So the idea is the same. We substitute into our equation. That gives us one equation, but we want to generate more by just multiplying by some sort of constant. Okay, let's look at number 7. So number 7 says to algebraically solve the system for all solutions. So I'm not sure what I did here. Oh, okay. So we have 2x plus y is equal to 4. So notice that in the first equation, y is already isolated. So do we really have to isolate y in the second equation? No. But if you wanted to, that's totally fine. I'm going to show you how to do it without it. So substituting that trinomial gives us 2x minus 3x squared minus 2x plus 112 equals 4, because again, this is also known as y. So from here we can combine like terms, and that gives us negative 3x squared plus 112 equals 4, because these two values cancel each other out. And then isolating or setting the equation equal to 0, we can subtract 4 on both sides, hence giving us negative 3x equals negative 3x plus 108 is equal to 0. And if you wanted to, you can simplify the equation by dividing by negative 3, giving us x squared minus 36 is equal to 0. Now, if you decided to subtract 108 on both sides and then divide by negative 3, you'll still get the same answer. It really doesn't matter. And from here, we see a difference of 2 perfect squares. So therefore, we can factor that, or we could add 36 on both sides, up to you. But I'm going to factor it as x minus 6 times x plus 6, which then gives us our two roots, which are x equal 6 and negative 6. And so from here, once again, if we're trying to find the solution to a system, we have to express it as coordinates. So expressing them as coordinates, we can take our equation that we looked at before and isolate y, because I personally wouldn't want to substitute our values of x into that. So we can isolate y that way, and then use that equation to solve for y. So using our two x values of positive 6 and negative 6 gives us negative 8 and positive 16 respectively. So again, our solutions has to be coordinates. So the first one gives us 6 comma negative 8, while our second coordinate is negative 6 comma positive 16. Let's move on to number 8. So number 8, notice that says factor completely. So every single time we see something like this, factor completely, that's just saying break it down into multiplication and do not solve for anything. Because this itself, there is no equal sign. You can't solve for x if there is no equal sign. So always leave it as it is. Do not go further. It's not that deep. So here we have 6 terms, 2, 4, 6. And so you might think, oh, the first thing I want to do is to combine like terms. There's nothing wrong with that, but it's just not going to be conducive or helpful in any way. Because whenever we see 6 or 4 terms, oftentimes that signals to us that we want to factor by grouping. And so now the question becomes, well, how do I know when to stop the grouping? Do I group in 3s? Do we group in 2s? How do we know? So what we want to do again is to look at the exponents. We have 4, 2, 3, 1, 2, 0. And so from here, to stop the groupings or indicate what groups together is often just saying the descending of the exponents. And the moment that it stops descending, that's when we cut off our grouping. So what do I mean? So 4, 2, so it's descending, that's good. And then suddenly from 2, it goes to 3. So that tells us that we're going to cut off our groupings after every 2. And if we look carefully, that does make a lot of sense. Because here we have a power of 1, and then we cut off our grouping because that starts as a power of 2 as such. So we have to make sure that when we choose to do our groupings, to always put addition signs in between to maintain equivalence to the original expression. So from here, we have to factor out the greatest common factor in the first 2 terms, giving us x squared times x squared minus 4. And then once again, we know for sure that we're going to have to repeat the x squared minus 4, thus giving us 3x times x squared minus 4. And then lastly, negative 40 times x squared minus 4. So now we can factor this even further and factor out the greatest common factor, or the common factor between all of them, which is the x minus 4, and now x squared minus 4. So that's going to give us x squared plus 3x minus 40 times x squared minus 4. And then now to factor completely, so factoring even more. So factoring this trinomial, we just think, well, what two numbers multiply to negative 40 and add up to 3? And that's going to give us x plus 8 times x minus 5. And then the last one is a difference of two squares. So that's going to be x plus 2 times x minus 2. And then we're done. All right, moving on to number 9. So number 9 says, algebraically determine all roots to the equation and express in simplest a plus bi form. So whenever we look at an equation, the first thing that we want to do is think, well, is there a way that we can simplify this equation? And if we notice, all of them are even. So what we can do first is divide everything by negative 2. We could divide by regular 2, but I just want to divide by negative 2 to make sure that the trinomial begins with a positive coefficient. So that's going to give us x squared plus 10x is equal plus 73 is equal to 0. So from here you could try factoring, but this is not going to be helpful at all, the 73. So instead we got two options. We have either completing the square or quadratic formula. So from here I'm personally going to say completing the square is easier and shorter, and you don't have to deal with having to simplify very large radicals. So let's do that by subtracting 73 on both sides, thus giving us x squared plus 10x, and then leave a blank equals negative 73. So from here we're going to complete the square by adding b over 2 squared on both sides of the equation, and b in this case is 10, so 10 over 2 squared will give us 5 squared, or in other words 25. So we're going to add 25 to both sides of the equation to maintain equivalence. And on the left side we're going to factor that into x plus 5 squared, while on the right side gives us negative 48. So from here, to solve for x, let's take the square root of both sides of the equation to eliminate the power of 2. And on the left side, that gives us x plus 5. And on the right side, here we can break down square root of negative 48 as square root of negative 16 times square root of 3, which then gives us 4i radical 3. And then we can't forget to write plus minus because we're changing a quadratic into a linear. So from here, solving for x, we subtract 5 on both sides, giving us x equals negative 5 plus minus 4i rad 3. But the question asks us to write it in simplest a plus bi form, hence why we have to make sure to put the I at the very end. So we have negative 5 plus minus 4 radical 3 and an I. So we have to remember, once again, we cannot put the I underneath the radical. That's not equivalent to just I by itself. And that leaves us with number 9. So let's look at number 10. So number 10 says factor over the set of integers. So let's see. So just says factor completely. Once again, this looks hard, but we want to translate it into an easier problem. So translating it into an easier problem, we can see that there's a repetition of this 5x squared minus 11x. So let's say that is equal to y. And we're going to translate this entire problem in terms of y. So we can write it as y squared minus 14y minus 32. And from there we know how to factor this, because we're just finding two numbers that multiply to negative 32 and add up to negative 14. And so that factors into y minus 16 times y plus 2. And so from here we can replace or substitute our, what was I saying? Oh, our 5x squared minus 11x into the y, thus giving us 5x squared minus 11x minus 16 times 5x squared minus 11x plus 2. So notice that the structure is still the same. The only difference is that now we have a product of two trinomials. And then from here we can factor even further by using mental math or AC method. I'm not going to go over it here because it's going to make the video extra long, but if you need additional help, you can check worksheet number 12, once again for the AC method, or the previous version of the video for the AC method. but this right here will give us 5x minus 16 times x plus 1 in the first trinomial, and in the second trinomial, 5x minus 1 times x minus 2. And that brings us to our last question, number 11. So number 11 says to solve the following system for all solutions, as such right here. And so from here we can choose to isolate any of the variables, x or y, because we notice that there's a coefficient of 1 in each of them. So it doesn't matter which one that we isolate as long as we use substitution correctly later on. So here I chose to isolate y. Why? I don't know, but I did it. So we can do that by subtracting x on both sides. And so from here, we're going to substitute that into the equation that we did not touch before, giving us x minus 2 squared plus negative x minus 6 plus 4 squared equals 26. From here, let's combine like terms of the negative 6 and the 4, thus giving us x minus 2 squared plus negative x minus 2 squared equals 26. And now let's multiply out the binomials, so that gives us x squared minus 4x plus 4. And then in the second one, that's going to also give us x squared plus 4x plus 4. Well, not also, because that's the main difference, the plus and this one's minus. Combining like terms, thus gives us 2x squared plus 8 is equal to 26. And then let's solve by setting the equation equal to 0 by subtracting 26, giving us 2x squared minus 18 is equal to 0. And again, you don't have to do it, but I'm just doing it to simplify the equation, dividing by 2 since both of these numbers are even. Thus gives us x squared minus 9 equals 0. And then you can either add 9 on both sides and then take the square root, or you can factor it as a difference of 2 squares, which gives us our two solutions of x equals positive 3 and negative 3. But once again, we have to find all solutions, and it's a system, so it has to be coordinates. So we have to solve for y by substituting our values of x into the equation that we isolated as such to find y. So therefore, that's going to give us negative 3 minus 6, therefore negative 9. In this case, negative 3 minus 6, or in other words, negative 3. So that gives us our two solutions, 3 comma negative 9 and negative 3 comma negative 3. Okay, so that concludes this practice exam. I just realized that I probably was speaking super fast for the entire thing, so maybe, hopefully you slowed it down to like 0.75 speed or something like that. I don't know. But if you have any questions, please feel free to ask me on Remind or in real life. Okay, and I'll see you next one. Bye.